right, today we're going to talk about introduction to lines. Are you ready? Okay, so first thing, let's talk about what a relation is. It is a pairing of input values with output values. Input is X, output is Y. So what are some relations? Let's talk about these things down here. So first, you could have an ordered pair that is a relation. Notice there's an input, there's an output there, right? So input, output, ordered pairs, a relation. Mapping. So sometimes they'll be like, here's a bunch of numbers in the input, and here's where they go in the output. So for instance, 0 goes to 8. So you could kind of view that as 0, 8, right? -1 goes to 9, 1 goes to 7, and 1 also goes to 10. So this would be like 1, 7, and 1, 10 right there. Over here you could have a graph, and there's an input. Notice this input here would be 15, and then the output here would be 68, right? So you could view this as a coordinate too, 15, 68. So these are just different kinds of relations that you may see. And we'll talk a little bit more about that in a second. A couple things that you should know. A domain is the set of all inputs, or what X can be. And there is a notation for this. So like in this case, the domain is whatever's happening there. Like we would write things in here, what X can be. And then there's also range. So it's all of your outputs, or what Y can be. And of course your range, write your stuff in here. There you go. Now, function. A function is a relation in which for every input there's one output. So you've got relations, you've got your input, you've got your output. There's no rules here. Everything's great. But you can take a relation and then specifically ask, is it also a function? And so the rule is for every input, there's one output. So we're going to talk about how you can determine that. Check to see if every input, there's only one output. So for instance, 2, 4. That's great. That works. But if you've got in your list 2, 4, and you've also got 2, 7, well, now when you put in 2, you've got a 4 and you got a 7. That's a big no-no. Okay, that is not a function. It's a relation. It's not a function. More than one point through any vertical line. Because if you think about a vertical line and there's points on it, you've got an input with 2 outputs. And let's talk about that down here. Determine if the following relations represent functions, and if not, why. So you can say here, when I have this number, I don't know what it is. Let's say it's 3. I've got an output here of, let's say, 2, and an output here of, let's say, -1. No, because for every input, there's not just one output. All right? Some people also say doesn't pass the vertical line test. Okay, so you can say doesn't pass the vertical line test, but understand that means for every input, there's not always just one output. Over here, you're good. The stud is closed. So even though this is open, it's not capturing that point. So that point kind of doesn't exist there. Okay, so this one's closed. So this is good here, and this one's good here. So if I draw a vertical line anywhere on this paper, it's not actually going through 2 points because these points are empty. There's not anything there. So yes, this is a function. Over here, it doesn't matter where I draw my vertical line. It's only going to go through one time. So yes, that's a function. Over here, if I put in 3, I get 5. Put in 4, I get 5. Put in 5, I get 5. Put in 6, I get 5. Now you may be like, oop, nope, that doesn't work because you have a bunch of 5s. Well, that's not true, because if I'm putting in something like a 3, I'm only getting a 5 out. If I'm putting in 4, I'm only getting a 5 out. It's what happened, like, it's if you put in a 4 and you got a 5 and then maybe a 7 out. Then it's bad. So actually, yes, this is totally a function. What about this one? If I put in -1, I get out a 9. We're good. I put in 0, I get out 8. We're good. I put in 1, I get out 7, and I get out 10. No. So no. And then the reason again why is for every input, sometimes there's more than one output. Sorry, I'm writing sideways. I apologize. Down here, same deal. If I do a vertical line here, look. What's happening right there? So why don't we just say no, doesn't pass the vertical line test. It's the same thing as saying for every input, there's not just one output. All right? Remember, I might be going fast, but you're able to rewind, rewatch, re-listen. It is your world. All right? So you do what you need to do. So let's talk through this stuff here. Dependent variable is dependent, that's why it's called that, on another variable. It's also the output. A lot of people mix these two up. So it's dependent on another variable. And so y is actually the dependent variable. A lot of people think it's independent because it's alone on one side. But actually, whatever you get for y totally depends on what you put in over here on the right-hand side. Independent variable is the variable that goes into the equation. It's the input. X is in the equation here. So that right there is your independent. This right there is your dependent. And then function notation is something else. It's useful to show input and output at once. We're used to saying like if we had up here like, y equals 2x plus 3, and I'm like, plug in a 2 for the x and work it out. That's fine. You'll get y equals whatever, right? Well, function notation is nice because this says they want us to find f of 5. So this is just notation here. It's actually, this stands for y, okay? So instead of writing y, we write f of x. So it's just notation. And you're going to substitute in here for x, you're going to substitute in that 5. So if we have 7 times 5 minus 9, and we work this out, we get 26. So f of 5 equals 26. You know where this is useful is plotting a coordinate, because if you had to write this as a coordinate, 5, 26. It's all like right there in your face when you're done with it, right? So that's what makes function notation kind of nice. Down here, slope or rate of change, it's the ratio of the change of y, or the rise, or the vertical distance, to the change of x, or the run, or the horizontal distance. You've seen this before. You may not have seen some of these, though. This just means the change in y to the change in x, which can be found with this formula. And some of you know it as rise over run. So all of those, same old thing. Down here, classifying a line by slope, you probably know these too, but that's why it's review. If you go up from left to right, it's positive in general. You'll notice right there, this is a positive 1. There could be a 2 there, could be a 10 there, there could be a 0.35 there. It doesn't matter. If it's positive slope there. This goes down from left to right, so you notice there is a negative 1 right there. And then over here, it's flat from left to right. So imagine if you're walking, right? You're not going uphill or downhill. It's easy peasy lemon squeezy right there. But then here, how you going to walk up that? You can't. Not fun, right? So that's undefined. That's how I remember it anyway. So this one's a horizontal line, so it's y equals whatever number it goes through. And this one over here is a vertical line, so it's x equals whatever number goes through. Parallel lines, they have the same slope. This is what the symbol looks like. This is probably how you'll see it on your worksheet if I talk about parallel slope. Perpendicular have opposite reciprocals. So remember, an opposite is you flip the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. A reciprocal means you flip the fraction. So if we have 2/3, now you're using 3/2. If you have 5, now you're using 1/5. Okay? Symbol looks like this, and this is how you'll probably see your perpendicular slope written. And obviously, if you multiply a number times its opposite reciprocal, you'll get -1. Okay? So moving right along, let's talk about some quick graphs. And you've probably seen most of this before. We're going to go through it again. So over here, first we have the slope-intercept form. Now, math people usually name stuff just really, they're not trying to trick you. They're really not. So if this is the slope-intercept form, it's probably going to tell you the slope and the intercept. Okay? So looking at this, M is your slope, and B is your y-intercept. Okay? Not your x-intercept, your y-intercept. And so looking down here, it says first plot your y-intercept, then complete slope from there. So first thing we plot is our y-intercept. So on the y-axis, we're going to plot a 4. Okay? And then from there, we're going to do our slope. Now, we just talked about what slope is. So this right here is your slope. So remember, this is your rise over run. That's what I like to use when I use a graph. And we have -3/2. Now, I'm just going to put the negative on the 3. Do you have to? No, you can put it on the 2. Doesn't matter, just put it on one of them. And then from this dot, remember, it's vertical over horizontal, or y over x. The change in y over the change in x. So we go down 1, 2, 3, and we go over 2. I want you guys to go all the way across the graph. 1, 2, 3 over 2, 1, 2, 3 over 2, 1, 2, 3 over 2. And I want you to go all the way across the graph, because then when you connect the dots, and please go through to the other side, it looks a little bit nicer and neater. Now I do want you to take your arrows from one side of the graph clear on over to the other side. Don't give me any little mini lines. Like some of y'all like to draw stuff like this. Don't do that. Take it all the way across. It matters later if I'm trying to ask you where two lines cross, you're going to want to see that. Okay, so let's keep on going to the next one. And don't forget, if I'm going too fast, you can rewind it, rewatch it, do what you need to do. Point slope form. So point slope form is right here. Now again, math people, we're really not trying to trick you, so you're probably going to be given a point and a slope. I mean, that's why we call it point slope form. So M is your slope. And then the point in here is x1, and I'm going to put a comma there, y1. Okay, so that x1 there and that y1 there is your point. Now look at this formula though, it has a negative sign in it. So this is the opposite of y1 and the opposite of x1. So when you're writing these here, remember then they're the opposite than you think. So be careful, and I'll talk about what I mean by that when I show you the example. And again, I've told you down here, plot your point, then complete your slope from there. So looking at this example here, when you're talking about your point, it's going to be the opposite than you think because the formula has a negative sign in it. So what is the opposite of negative 3? Positive 3. And notice I'm writing it with my y. That's y1. And what's the opposite of positive 1? Negative 1. All right, so there's your x1, y1 right there. So just be real careful with your signs. Your slope in this case is 2/3. So remember, this is your rise over run. So we're going to plot that point first, and we're going to do our rise over run from there. So negative 1, 3, pop a dot, then go up 2 to the right 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Connect those dots because that's as far as we can go. Clear on over to the other side. All right, so there's point slope form. Okay, so last we have standard form. It doesn't show you a lot, but it does show you something. I know that sounds really crazy, but let me tell you what I mean. It's really good at showing you x and y intercepts because you can kind of cover stuff up. And I can't really show you this without doing the problem. So let's just go on and do the problem. If x is 0, put your finger over the 2x. Now I'm going to cross it out, but don't cross it out on your paper because then you're just going to have to erase it in a minute. Put your finger over the 2x. If x is 0, that goes away. Now look at this equation. What is y? Then y is negative 3, correct? So we have our first point. We have x is 0, y is negative 3. Okay, so now put your finger over negative 4y. I'm going to cross it off on my paper because you can't see my finger, but you put your finger over negative 4y. Because negative 4 times 0 is 0, right? So if y is 0 and we solve this, what's x? It's got to be 6. So there is our other point now. So we go over here, x is 6, y is 0, and we have it. And that's all you need to plot for this line. You know, connect it, go clear on over to the other side. And then that is it for today's notes. They will probably be checked in class, so make sure you are ready to go, and we will expand on this next time I see you. Until then, bye-bye.